All right, last two sections of the chapter both deal with quadratic inequalities. So we're going to do two different things with quadratic inequalities depending on whether they have a y or not. If there's a y in the inequality, I will ask you to graph it because that's in terms of x and y. If there's no y, I'll ask you to solve it. So the videos I'm making here are to cover those two possibilities. So the first thing we're going to talk about is graphing a quadratic inequality. Now you may remember we graphed linear inequalities before, and linear inequalities could have like a boundary that was dotted or solid, and that depended on whether or not the inequality was equal to or not equal to. And then we used a test point, usually 0, 0, to determine which way to shade, and that could be above or below. This process, graphing quadratic inequalities, is exactly the same. The only difference is that the boundaries aren't shaped like straight lines. The boundaries are going to be shaped like parabolas. Oops, poor shading. So let's just walk through this problem. I'm asking you to graph y is less than negative 2x squared plus 4x minus 5. Notice this is in standard form. So we're going to have to remember how to graph a standard form parabola, so we'll walk back through that in a second. Now, first things first, is the boundary solid or dashed? Well, you can see this is just less than, it's not equal to, so this boundary is going to be dashed or dotted. Now, we're ready to graph the boundary. So since this is in standard form, you want to make a t-chart that has 5 points. Your vertex is going to be in the middle. Same thing happens with vertex form. But in vertex form, you can just look at the equation and get the vertex. With standard form, you have to do the h is negative b over 2a. By the way, if you have a hard time remembering that, remember the quadratic formula. X equals negative b plus or minus square root b plus 4c over 2a. The stuff that's not the square root is how you get the vertex. So my b here is 4, my a is negative 2. So it'll be negative 4 over negative 4, which is 1. So that's my x value of my vertex. So to find the y value, I'm going to take that and plug that into the equation. Now, by the way, when the boundary itself is sort of like when y equals this stuff, the inequality part comes in when you're trying to shade. So when you're trying to make your t-chart, you can treat this as if it's the equation and then worry about the inequality when you're trying to shade. So I'm going to plug 1 in. Let's see, that's negative 2 times 1 squared is negative 2 plus 4 times 1 minus 5. I think I get negative 3. So now I want numbers that are around 1 to plug in. So I'm going to do 0 and negative 1, 2 and 3. And I would do the same sort of thing, plug them into the equation to see what values I get. So when I plug in 0, I get negative 5. When I plug in 2, I get negative 8 plus 8, which is 0 minus 5. When I plug in 3, I get negative 18 plus 12, which is negative 6, minus 5, which is negative 11. And when I plug in negative 1, I get negative 2, minus 4, which is negative 6, minus 5, which is negative 11. So now, I'm going to plot this. And again, I'm going to give myself some room down here. And I'm freehanding this, so it's not going to be the prettiest graph, but that's okay. So I'm going to plot negative 1, negative 11, 0, negative 5, 1, negative 2, and so forth, and so on. And the boundary was dotted, so I'm going to connect this with a dashed line. And arrows in the end. And now all I have to do is figure out which way to shade. So to do that, there's a couple of ways of doing it. If your y was by itself to start with, you can look at the inequality direction and say y is less than. Well, y being less than means everything below a graph, because the y values are smaller below. If it was greater than, it would be above. So I can simply look at that, say this is below the graph, and I can shade below. But that's only if the y is by itself when you're looking at the inequality. Or I can do what we did before, which is a test point. If I picked a test point, our logical one is always 0, 0. and you test it by plugging it into the inequality. And seeing if that's true. So 0 is less than -5? No. So you don't shade where the test point was, you would shade the other region.